You know that sinking feeling, walking out into your garden the morning after a massive storm, only to find your prized greenhouse twisted, glass shattered, and your plants completely ruined? It's a devastating reality that countless growers face every single year. Well, welcome to this explainer. Today we're going to unpack the actual physics of extreme weather and show you exactly how to engineer your greenhouse to survive hurricane-force winds. We've synthesized expert research and real-world data to help you protect your investment. Let's get into it.
To kick things off, look at this staggering quote from a UK installation team. These guys deal with hundreds of post-storm wreckages every season, and what they're saying here beautifully illustrates a crucial truth. The real enemy often sneaks inside the structure. A greenhouse that looks perfectly fine on a calm Saturday can literally turn into a kite when 50-mile-per-hour gusts hit.
Okay, let's quickly run through our roadmap for this explainer. We are going to cover the physics of wind damage, site placement and windbreaks, framework and glazing upgrades, foundations and anchoring, advanced structural reinforcements, and finally, storm prep and recovery.
Let's jump right into Section 1, the physics of wind damage.
Before we can fortify the structure, we have to understand the invisible aerodynamic forces trying to tear it apart. Experts call this the double force effect. Imagine your greenhouse acting like a giant balloon. When wind rushes over the top, it creates uplift, pulling from the outside. But if a door or vent blows open, that rushing wind suddenly inflates the structure from the inside, pushing outwards. When those two forces combine, the load on your fragile metal frame instantly doubles. That is exactly where catastrophic failure happens.
And it's not just a flat wall of wind hitting the side, right? Thanks to Bernoulli's principle, fast-moving air rushing over the roof acts exactly like an airplane wing, creating massive uplift. Combine that uplift with lateral racking that twists your frame out of square and intense vibrations that cause lightweight panels to literally pop right out of their tracks at 65 to 70 kilometers per hour. It's a total recipe for disaster.
Moving right along to Section 2, site placement and windbreaks.
Before we even pick up a single tool, we can naturally deflect the wind through smart orientation. By simply aiming the narrowest part of your structure, the gable end, which is usually around 2 meters wide, directly toward the prevailing storm winds, you drastically shrink the structure's sail area. This one simple design consideration cuts the twisting force on your long side walls by more than 50%. That is a huge reduction in metal fatigue.
Now, I want you to remember this number: 10 times. A semi-permeable windbreak, like a hedge or a slatted wooden fence, actually cuts wind speed by 50% for a distance measuring 10 times its height downwind. So if you've got a 2-meter tall hedge, you get 20 meters of highly effective, low turbulence protection. Solid walls, on the other hand, just create destructive swirling eddies. So a natural, filtering windbreak is absolutely your best defense.
Okay, Section 3, framework and glazing upgrades.
Now that we've manipulated the airflow around the site, let's evaluate the very skin and bones of your greenhouse. When looking at glazing, notice that while 6 to 10 millimeter polycarbonate is wonderfully impact resistant against flying debris, it's super lightweight and flexible. That means it needs serious mechanical locking to stay put. Toughened safety glass, conversely, provides extremely high wind resistance simply because its heavy, rigid mass naturally fights against uplift and twisting.
And here is a massive cost-benefit moment. Standard spring clips are essentially the weakest link in any aluminum greenhouse. They rely completely on friction and they fail all the time under heavy suction. Upgrading to continuous bar capping, which physically bolts the glazing down along the entire length of the frame, completely eliminates the chance of suction pulling your panels out. It is such a modest upfront cost, but it prevents thousands in total loss damages. A real game changer.
All right, Section 4, foundations and solid anchoring.
Listen, a heavy-duty galvanized steel frame means absolutely nothing if it isn't anchored into the earth. For large, permanent setups, following these 4 steps for a concrete pad creates an impenetrable base. The depth is absolutely essential here. Getting below your local frost line prevents ground heave. That's when freezing moisture expands and literally pushes your uneven foundation up, which warps the metal frame and cracks your expensive glass.
But what if you're installing on bare soil or a wooden platform? Well, the specific technique for U-shaped rebar brackets is critical. They have to pass completely over the bottom structural frame before plunging into the soil. Never just hook them beside it. And if you're using ground anchors, they need to go at least 450 millimeters down to actually resist the upward pull of a severe gale.
Now for Section 5, advanced structural reinforcements.
So your foundation is solid. Let's look at how to build the frame itself into an unshakable fortress. You can dramatically boost a standard kit survival rate with these tricks. Adding 45-degree diagonal supports on those vulnerable end walls completely stops the frame from racking. Tensioning steel cables directly over the roof to ground augers actively pin the structure down against aerodynamic lift. And using screws with neoprene washers, that lets the frame absorb intense storm vibrations without cracking your polycarbonate panels.
And for massive structural integrity, here's one of the absolute easiest DIY hacks. Apply a generous bead of low-modulus silicone around the base rail and the panel overlaps. This entirely blocks those tiny, high-pressure drafts. Remember the double force effect we talked about earlier? Blocking all air entry ensures your greenhouse cannot inflate and explode from the inside out.
Bringing us to Section 6, Storm Preparation and Recovery.
You've engineered a fortress, but human intervention is absolutely your last line of defense when the storm warnings flash. Take 15 minutes before the storm hits to run this checklist. The push test is absolutely critical. Push your closed door from the inside. If it flexes outward more than 5 millimeters, the wind is going to get a grip and rip it open. Also, you must remove the wax cylinders from your automatic roof vents. Severe wind suction can actually trick those mechanisms into opening right in the middle of a hurricane, dooming the whole structure.
And we can't forget the recovery phase. Grab a 10mm socket wrench within 24 hours after the winds die down and retighten every single bolt on that frame. Storm vibrations cause hardware to back out, and one loose joint today will absolutely become a catastrophic failure during the next storm. Routine maintenance is just non-negotiable.
Quick disclaimer here before we wrap up. Please remember that while this engineering guidance is thoroughly researched and backed by expert installation teams, you must always account for your specific regional variables, things like extreme snow loads, local wind zones, and your specific soil type. Always consult a local professional if you're ever unsure about your setup.
So, as you gear up for the next stormy season, ask yourself this final question. Is your greenhouse a rigid, unanchored sail just waiting for the right gust to break it? Or is it a deeply anchored aerodynamic system working intelligently with the forces of nature? Taking action on these structural reinforcements today guarantees you'll be growing securely for decades to come. Thanks for joining us for this explainer, and we'll catch you in the next one.